from KHD. Matthias, if you'd like to prepare your slides. Matthias has more than 25 years experience in the cement industry. Throughout his career, he's predominantly worked on the technical innovation and optimization of machines and processes for the cement industry. In 2008, he left KHD to found Exergy, an independent consultancy serving the international cement industry that he led as managing director until 2020. Matthias returned to KHD in early 2020, and as Chief Technology Officer, he is responsible at KHD for overall development of the company's product and service portfolio and makes sure that the group maintains its innovation-focused orientation through extensive R&D and engineering excellence. And today he's going to present on AFR and low CO2 technology for the Asian cement industry. So, Matthias, over to you.
So thank you very much, Tom, for that friendly introduction. I hope you can see my screen now.
There we go. That's perfect. Thank you.
All right. Perfect. So good morning also from my side. Good afternoon, ladies and gentlemen. It's my pleasure to be honored to be part of this conference today, which is dealing with a very pressing and at the same time interesting subject for the cement industry. I guess we all share at this moment, this time, the same feeling of urgency and still uncertainty, because we feel that there's a lot of new things coming up, new requirements from markets, politics, societies coming up to us in the cement industry, and we all sort of like keep asking ourselves, what can we do to respond to all these new requirements that are falling onto the cement industry in a dynamic and in a matter of speed like that was unprecedented in the cement industry. So I thought I'll try to make a contribution today and try to give some recommendations on what especially the Asian cement industry could opt for as a way to respond to these multiple and sometimes a little bit unclear requirements coming up to each and every cement producer. So today my presentation is titled AFR and low CO2 technologies for the Asian cement industry. And I'd like to connect first to what has been investigated yesterday. If I get these slides to change. Oh yeah, there we are. So I'd like to connect to the market outlook. This is the result of a study by BNP Paribas. They shared their most recent views also yesterday. This slide I have taken from a study that was published before what has been published yesterday. But I think the main statements here are remaining identical. The main statement is that there will be some catch-up effect in cement demand from what the cement industry and the whole economy has been suffering from throughout the last years on the Corona crisis. And also some fundamental demand is being reflected here, and especially if we look at the Asian region, we'll see that the prediction is that there will be conceivable up to strong growth to be expected in cement demand in the Pacific, in the Asian region. So there is a demand for the cement producers to be able to satisfy an increased demand for cement. And at the same time, we do have some technological requirements coming from everything that is around the CO2 subject. And what I've displayed here is the roadmap as it was published by the International Energy Agency in connection with the World Business Council for Sustainable Development and the Cement Sustainability Initiative. Some of these organizations had been transferred into new types of organizations recently, and you know that the publication date of this roadmap is also some years ago. But in the essence, this roadmap shows quite clearly the main levers on which we have to act in order to achieve the Paris Agreement goal of maximum 2 degrees centigrade average temperature increase. And these main levers are energy efficiency. Let me put the laser pointer so that you may be able to follow my cursor better. So the main levers are energy efficiency, alternative fuel use and other fuel switching options, clinker substitution, and carbon capture and storage. You know, these terms may have changed along the very dynamic development which we're subjected to. Today we talk about carbon capture, utilization and storage. Maybe the percentages showing the potentials here are being revised as we move along the development. I guess clinker substitution today would be judged with a higher potential. But still, these 4 technological pathways subsumize the entirety of technological levers which we have to work on in order to get the CO2 emissions reduced and arrive finally at a carbon neutral cement industry. And within this package, there's a multitude of technologies, and I think one of the major challenges today is to pick the right way to go within this huge amount of possibilities that is hidden behind all this. And today I'd like to make a contribution that can offer some proposal for the Asian cement industry specifically to get going, to get on the path of carbon reduction and carbon neutrality in small steps, big steps, scalable technologies, and short-term proposals and long-term proposals. To give another aspect on this subject matter, I'd like to show here another interpretation of another party, another company, the On-Field Investment Research Group has also been investigating what would be the most likely response of the multinationals in this decade. And with all the multitude of technological options in hand, the question is, what are they going to do as first movement, as first steps? And the result of this group of analysis was clearly that most of the cement producers will focus on 2 things first. The first is to increase the use of alternative fuels massively. And the second, to reduce the amount of clinker in cement. These are 2 very short-term achievable levers to reduce production costs and to reduce CO2 emissions. And that's why I'd like to focus today on these 2 levers, because I believe this can be very attractive to get going towards the low carbon industry. So my first subject will deal with alternative fuel technologies. And as I said, it is nicely scalable. Alternative fuel utilization requires, first of all, of course, the suitable burning technology, firing technology. So we address subjects like burners and like, for example, shown in this case, the kiln burner can provide a good contribution to an increased alternative fuel firing rate. For that, the burner needs to be designed, or its design needs to be adapted to be able to burn lumpy secondary fuels, to provide enough mixing for the lumpy secondary fuel to be ignited. The burner design needs to be adapted also for oxygen enrichment and hydrogen enrichment, which will be coming up as alternative low carbon fuels, and also to facilitate the burnout of maybe lumpy hard to ignite fuels. What you see here is the latest design of the KHD Pyrojet burner, which can be retrofitted very easily into each and every kiln. Taking it a step further, I'd like to introduce to you what we call the pyro incinerator, which is a modular system. You see that in that dark gray box attached to the calciner here, a modular bolt-on system to provide incineration facilitation for hard to ignite fuels. You can imagine that if you start using RDF or other lumpy fuels, you need to help incineration, ignition. And this is an easy flange-on retrofittable module to increase your RDF feeding rate in the calciner. Next thing, of course, is the well-known combustion chamber. I guess I don't have to spend much time on explaining this. That's a device that is already commonly known in the process industry, in the cement industry. A device that takes the utilization of lumpy secondary fuels one step further with a dedicated burner on top of the combustion chamber, also retrofittable to a number of calciner and clinker production plants. What I want to put your special focus on is a new technology that we developed in the recent years, a system we call PyroRotor. The PyroRotor consists of a rotating kiln, which is sitting on top of the clinker kiln, and that is providing the most robust and most versatile type of AFR reactor that is available for the cement industry. The concept of the rotating kiln comes with a lot of benefits. First of all, there is a constant movement of the material inside the kiln, which avoids clogging and blocking. And at the same time, it provides new surface for the oxidization and for the burnout of the secondary fuel inside the rotor. It's most robust, it's tried and proven, it's suitable for especially material with poorest burning properties, very coarse and low pre-processed fuels. Even whole tires can be burnt in this. And if we look at the CO2 aspect, of course, we're dealing with biogene fuels. Biogene fuels often come with a lot of humidity, are very slow to burn, very slow to ignite, and need a long retention time. If we talk about wood, for example, retention time in this PyroRotor can be very long. The rotational speed can be adapted according to requirements. So this is a very versatile device which I'd like to show you in a little animation. I hope we get this going. I hope you can see this now. Here you can see the PyroRotor as it is sitting in between the calciner riser duct and the tertiary air duct connection. You see that in terms of design, there is nothing really special about it. All the elements we know from building rotational kilns like we've done for many, I can say, century already. And if I open this up, you can see that inside the PyroRotor there is brick lining, of course, because we are feeding hot gases and running a combustion inside that system. You see the airflow coming from the tertiary air through the PyroRotor. And if I now start feeding material into it, you see that the alternative fuel forms a layer in the rotation, in the rotating kiln with surface renewal, constant surface renewal that makes the material accessible for the combustion. And in the end, the off gases are being mixed into the calciner riser, so that in total we have a flow sheet of this system, like to be seen here. We branch off a little bit of tertiary air guided through the pyrorotor. We can set the lambda value according to requirements. We can run the pyrorotor in reducing atmosphere, so to create also a beneficial reducing atmosphere that is reducing the kiln produced NOx as we travel down the calciner into a mixing chamber to have the residual burnout of CO and then come into the preheater with a totally burnt out NOx reduced gas. The amount of coarse secondary fuel to be fed into this pyrorotor is exceptionally high. We have several references installed meanwhile with substitution rates up to 100% of calciner fuel consisting of lumpy, and I talk about 3D size, 300 millimeter rubber pieces, so very coarse material that requires only a minimum amount of pre-processing. And that's especially interesting for regions like Asia, where there is not yet any really established scene and environment of RDF processes, so that you can take municipal waste and pre-process it only to a very minimum amount and then feed it into the pyrorotor. So we have all kinds of secondary fuels being utilized in the pyrorotor, and the clients use it all around the world. We have specifically references in China and in Korea, where production of feed rates up to 15 tons per hour have been realized. But of course, this depends very much on the type of fuel you feed in. We have highly reactive fuels like plastic and rubber, which of course can ignite fast and burn out fast. But if you take, for example, biogenic fuel or moisture-rich fuels, they need a longer time to ignite and burn out. The versatility of the pyrorotor, the different speed you can make it rotate, and the lambda value, which you can set by setting the tertiary air flaps as you like it, provide a very wide range of flexibility of operation for the pyrorotor. Now, I'd like to switch over to the so-called low carbon technologies, which is generally a subject that seems to be a little bit further away on the time arrow, but as experience tells, the large cement producing groups already run their pilot projects on these low carbon technologies. And I feel this movement towards low carbon technologies coming to us much faster even than I expected it a year ago. And so we are working, like everybody in the industry, I assume, already very concretely on pilot projects on various kinds of technologies for the low carbon future of the cement industry. And the two subjects I'd like to mention here in today's presentation are referring to CCS and oxy-fuel plants, or I should rather say CCUS and oxy-fuel plants, which cover the subject of end of the pipes carbon capture technologies, but also integrated concepts like oxy-fuel processes, which are running the clinker production process without the usage of air, but recirculated or in any case oxygen enriched gas as a combusting agent. And the second subject would be referring to the target of clinker substitution, and a widely used approach here is that of clay calcination. And let me start with the clay calcination here with an outlook of, or with a deposit map for clay. And we see that the kaolin deposits, which are necessary for using clay calcination as a technology to produce an SCM from calcined clay, is very lucrative also in the Asian region, where there are huge deposits of kaolinite, which is necessary. So that might be a very interesting technology for especially the Asian region to reduce their clinker factor and produce calcined clay and mix it into cement. And for this reason, we have developed technology for clay calcination, which I'd like to briefly introduce to you. Let's start on the left-hand side with drying and comminution of raw material. Clay usually comes as a moist product and needs to be dried. So like in a conventional clinker production process, we are running a counterflow process here by utilization of the off-gas of the core process, which comes out with hot gases, to use it as a drying agent for the wet raw material feed. A favorite installation would consist of a hammer mill, which feeds its outlet into a flash tube that is used as a dryer. We have a classifier here sorting out the ready-made, the coarse product back to the hammer mill. The fresh feed of the moist material coming in here into the hammer mill, and then into the classifier. The ready dried material will be collected and then fed through a bucket elevator into the cyclone stages that are cascading down like a regular cyclone preheater, and finally end up again in a flash tube where the calcination takes place. So you can see that using technology that is well known from cement plants, a lot of experience in KHD and building cyclones and flash tube calciners. And finally, the calcined product will be transferred into a recuperation and product cooling area where we are using cyclones again to cool down the product. So nothing exceptional. It's just a new interpretation, a new utilization of well-known components for a new purpose. And if you look at how this looks in a plant view, you see it comes very close to a conventional cyclone preheater, just a little bit rearranged, and the hammer mill introduced into it. So you see in green the drying and comminution part. In a red circle you see the preheating and pre-calcining part, which is the large visible flash tube calciner here. And then finally we have the recuperation and product cooling. So it's a counterflow process, highly energy efficient, like we know it from clinker production. As a special feature, we have developed a specific two-stage process with optimized oxygen staging, which provides for color control and optimized heat utilization. This is necessary because if you don't control the oxygen content during the calcination, you will have a non-gray product, and in the cement industry we just like the color of gray. And with this it's possible to control the oxygen content and with that to control the color. As the last point of technology I'd like to mention today, I'd like to give a little bit of information on CCUS and oxy-fuel plants. I guess the subject of carbon capture as a bolt-on end of the pipe amine scrubbing technology is well known to everybody. It's something you just flange on at the end of the process. A well-known technology that is available already. What is more interesting, because it's more energy efficient and because it's more it's reducing costs also on the carbon capture side, is to run cement plants as oxy-fuel plants. Oxy-fuel means that you don't use air for the combustion, but you use an oxygen-enriched gas. I guess we're going to hear from ThyssenKrupp already their proposal on their oxy-fuel process as well. But what I'm showing here is something like a classical, very flexible oxy-fuel flow sheet. You see the preheater and the precalciner, the rotary kiln and the cooler as the core of the clinker production process. And what's different from a regular process is that you take the off gas of the preheater well, you do some energy recovery, but in the end you recycle it and bring it back into the cooler and add some oxygen to it. So you run this process with the recirculated CO2-rich gas, which you enrich with oxygen, just so much that you can burn your fuels. And then you can constantly branch off highly CO2 concentrated off gas and lead it towards purification and compression, and then transport and storage or utilization as you like it. So in order to run these processes, there's not much that is needed to be changed relative to today's clinker production lines. Basically, you'll have to manage the combustion regimes. That means you'll have to adapt your burner to be able to run in a CO2-O2 atmosphere instead of an N2O2 atmosphere, which is easily possible if you know what you're doing. So a little adaptation in the burner is necessary. And what's also necessary is to avoid false air from leaking in, because the nitrogen in the ambient air that is sneaking into the process will provide a contamination for the off gas, which you like to concentrate your CO2 to the maximum extent. So with a little bit of adaptation to C-lakes, combustion machines like burners, and some other little devices, it should be possible also to retrofit technology to convert a conventional kiln plant into an oxy-fuel plant. We are moving to these technologies. I guess within a year from now, we will be able to talk more about it. The only thing I can say at this moment, everybody's very busy in developing these pilot projects, and we will very soon have more progress in this respect. So with that, I finish my presentation for today, pointing out that KHD has a long tradition in innovating technologies for the production of cement. This is just a little time arrow of all the innovations that KHD has been putting to the cement industry in the course of just the recent history of KHD. You see the latest innovations of KHD at the right-hand side with the pile rotor and the calcined clay plant. And we would be looking forward to continue this innovative history and to fire our innovative genes together with you during this very interesting period of time that's coming up to us so rapidly. I think we have to get all our brains together, everybody, and cooperate all across the sectors and all across the desks in order to manage to respond correctly to this requirement that is given to us, to this challenge. So let's get things done together. We will be happy to cooperate with you. Thank you very much for your attention.
Thank you very much, Matthias. That's a really interesting presentation. You've kind of touched all the main themes there. We've looked at alternative fuels, the clinker substitution, and now the CCUS, as you say. There's so much technological development now. Some of it's in really quite early development, and some of it is literally on the cusp of being installed for the first time in cement plants. I don't know, let's maybe just quickly ask one or two questions on each piece. The pyrorotor was the first section looking at the alternative fuel substitution, and you've got several references for that. Just to give us an idea of, all of these things are big are capex issues. There's a lot of priorities that each individual cement producer will have. If you're going to go into alternative fuels, and a lot in Asia, the average is around 3%, which is still at the beginning of the journey. Where do people start? Is the pyrorotor somewhere to start, or is it the big thing that once you've got an up and running alternative fuels program that you would then commit to? Because it's a significant investment. It's a kind of rotary kiln in essence. So how would it fit into that journey of people who are now starting alternative fuels?
Yeah, that's a good question. That depends very much on the strategy of the cement producer, and also very directly on the availability of sufficient amount of municipal waste, I would say. Because the pyrorotor is hungry, it needs to be fed with a consistent amount of lumpy secondary fuel. So I would say if you are a cement producer very close to a big city that has preferably a problem in municipal waste dumping, and you can solve that problem for that municipality, you will get a good gate fee to dispose of all that waste. I think then the return on invest would be something around 1 or 2 years. If you are far away from a source of consistent, big enough mass flow of lumpy waste, then it would probably not be feasible. Then you would be better off starting with a smaller mass flow component. So it depends very much on the availability of municipal waste, or if there's somebody within the vicinity of 200-300 kilometers that has a real problem with waste, then this could be a very interesting solution. We see that in China. In China, they have a certain type of hazardous waste even to be burned inside this pyrorotor in a cement kiln. So it is financially very lucrative for them to run the pyrorotor.
Yeah, and we heard yesterday in the cemtech presentation, there are big initiatives now to clear up plastic and plastic mining the landfills. We saw examples from China clearing up the Yangtze River, where huge quantities of waste are being diverted into alternative fuels, and I can see a very direct sort of application there with the mega cities as well, providing the municipal waste.
Absolutely, Tom. And what is very important to understand, if you cut down and pre-process this plastic waste to a regular, say, high-quality fluff, as we know it in Western Europe, for example, with an edge length below 30 millimeter, you lose half of your money in this pre-processing. And this is something you don't need to do in the pyrorotor.
Okay, so that was the first thing, and a really interesting piece of technology. We looked at calcined clays quickly. So this is now, is it a pilot plant? It looks like it's a flash calciner essentially based system. You pointed out the availability of kaolinite in a lot of the Asian regions that we've been talking about. There are a few questions asking, how much kaolinite percentage do you need in the available clay? How many calcined clay plants has KHD supplied so far? What kind of capacities can you handle? Do you want to just talk around those questions, and then let's just touch on the color issue, which is also important.
Yeah, okay. So like in every emerging technology, there is nothing like a blueprint or one size fits all solution. And this refers to this and the amount of kaolinite you need for a product as well. That refers very much to, in the end, the quality standards you need to meet in your cement. The only thing that's sure is the more kaolinite you have, the better the quality will be in terms of the hydraulic properties of the SCM that you produce with it. But you can also, of course, counteract with grinding cement finer that will increase its strength in the end. So that has a very tight connection to the cement quality standards in the end. How many calcined clay plants have we supplied already? Unfortunately, until now, 0. But we are in talks with lots of cement producers to build up pilot projects. I expect this to be contracted very soon because everybody's really active with it. I know that, of course, ThyssenKrupp has already the first plant installed. That's a technology that is coming up. Undoubtedly. And now the last question regarding the color control. That's a feature that we have been developing and patenting. It consists of recirculation. Basically, as you see it from the mechanical point of view, from process point of view, it means that we are splitting this process into 2 stages where we set the chemical reaction regime into 2 different and optimized sections, while we control the oxygen at that time when the calcination takes place, which means that the red brownish color of the calcined clay will not come up. It will stay gray. And at the same time, we can optimize the energy efficiency with this recirculation concept.
Thank you very much. Matthias, we've got a lot of questions in the Q&A. You may want to look at some of those. We're going to have to leave it there for now, but it was a really fascinating presentation and really appreciate your time today. So thanks very much to Matthias from KAHD.
All right, thank you.
We're going to move now on to our second presentation, and I'm delighted to be able to welcome Tongo Sui from Sonoma International Engineering. If you'd like to share your presentation now. Tongo is currently Vice President of Sonoma International Engineering, has been intensively engaged for over 20 years in the R&D of low energy and low CO2 clinker cements as a solution to addressing cement and concrete sustainability. Before joining Sonoma in 2010, he worked as Vice President of China Building Materials Academy between 2006 and 2010. He's also a visiting professor at Tongji University in China, University College London, and a senior advisor of the China Cement Association, as well as being active in many international organizations and co-chair of WG5 for cement innovation under the GCCA. Hugely experienced and with a fascinating presentation now. I'm going to hand over to you, Dr. Tongo Sui. He's going to speak about technical solutions responding to the carbon neutrality goal of the cement industry.
Thank you, Thomas. Thank you for the kind introduction. Good morning, good afternoon, colleagues. I really appreciate the kind of conference organizer for inviting me to attend this important conference. I'm not quite sure if the slides is good or not.
Yeah, we can see them, but if you would like to put it into presentation mode, in the bottom right, you could press the icon, which will show the slides.
Just a moment, sorry.
We can see them. Okay.
I don't know why.
Yeah, that's the one. That should.
Is that okay now, Thomas?
Okay, we can see them. Yes, that's perfect.
Okay.
Thank you. Yes, we're there.
All right, good. Today, I'm very happy to share with you, the technical solutions responding to the carbon neutrality goal of Chinese cement industry. This is also the effort of the Chinese cement industry to respond in the statement that our President Xi Jinping made in last year, September, that we aim to have CO2 emission peak before 2030 and achieve carbon neutrality before 2060. So today, my presentation will mainly include the following three parts. First, a quick review of Chinese current situation of Chinese cement industry. As we know, China is producing more than half of the cement in the world perspective. So we have seen in the last 50 years the dynamic increase of Chinese cement production. The highest production output actually happened in 2014. And then actually the cement industry of China actually experienced a steady decrease a little bit, though actually there's some up and down, but we have seen that we are now in the phase of decreasing of the production amount. But even that, actually we see that when we look at the figures of per capita yearly consumption of cement, we are still very high, 1.3 tons per capita. And also in terms of CO2 emission from cement industry, we actually have account for around 13% of CO2 in China for cement from cement industry. Another characteristic of Chinese cement we have seen from the figures that it's the higher ratio of clinker substitution. We know that actually clinker substitution can give immediate effect for CO2 emission mitigation. So we have seen actually the lowest clinker factor of Chinese cement happens around 2014, and in recent 3-4 years there's a little bit increase of the clinker factors in the Chinese cement. But that doesn't mean actually we use more clinker in the concrete. But what we didn't use, do not use in the cement production, we can also use it for concrete. So it's more or less the same effect in terms of CO2 emission per cubic meter of concrete. We know that the CO2 emission, especially the direct CO2 emission, actually is closely associated with clinker output. Here actually it shows us the diagram of the Chinese cement industry for clinker output and direct CO2 emission for Chinese cement industry. We have seen actually a little bit increase in the recent years. More or less actually 1.3 billion metric tons of direct CO2 emission from Chinese cement. That means that it's a huge amount of CO2 emission. Also actually means it's a huge challenge for Chinese cement industry in the future, especially in terms of the CO2, the carbon neutrality in the future, 2050 up to 2060. In the second part, I will give you some examples of best available technologies and emerging technologies in China, contributing the cement sustainability and the carbon neutrality. Just follow the same principle of the technical roadmap for low carbon cement that launched by the IEA and the former CSI. We have actually best available technologies in China for continuous improvement of the energy efficiency, the thermal energy efficiency, as well as the power efficiency. And we also have actually equipped, more than 80% of the Chinese facilities with waste heat recovery system. And the second part with best available technology for alternative fuels raw materials. Mostly we focus on the co-processing of different wastes. For example, the municipal solid waste, hazardous waste, and sewage sludge. So far, we have equipped something around 100% facilities dealing with different waste, municipal solid waste, sewage sludge, and hazardous waste. Unfortunately, the percentage of the co-processing using alternative fuels is very low, something around 2%. That means also in the future, the more potential will be, will be placed in we can use for for using alternative fuels for Chinese cement industry. So in this regard, actually, so our last, the first speaker today is our PhD colleague, Massives. Actually, they show us actually the alternative fuels utilization. I believe that's really very much welcoming by the Chinese cement industry in the future. The third best available technologies lies in the product development and production of the low carbon cement, mainly in two aspects. First, we have developed development used for more than decades. Actually, the different type of low carbon clinker cement. For example, the yeelimite, the calcium sulfonaminate based, the baelite based, low carbon clinker cement. So I won't talk more about this, because in the previous cemtech Asian conference, I introduced the low carbon clinker cement, in China. I will also actually, mentioned it for during this my presentation, the LC3, the calcium. The limestone calcium clay cement, just as actually our PhD colleague, I just mentioned, just presented, more or less, we are in the same track of using the same solution, the flash calcining system to calcine the clay to make the low carbon cement more efficiently. And the second part, best emerging technologies for CCUS, that's actually it seems to be well recognized that we are more or less relying on 50% of the of the CO2 emission mitigation by the CCUS in the future. So that's why actually cement sector is considered as one of the harder to abate sectors. The first example I wish to present is the demonstration project with the AI more aided modern manufacturing technology. The project is located in Hangzhou, near Hangzhou. That's where can CNBM cement. So the project actually is a new dry process. Is a 6-stage new dry process facilities with a capacity of 7,700 tons per day capacity, generating 30 kilowatts by the power generation from the waste heat recovery system per ton of clinker, with also the modification of the AI system where we actually have the build the cement facilities with less than 65 steps, and a number of advanced KPIs, for example, the thermal consumption and the power consumption, and also the pollution control parameters are also very good. A second example I was given for this co-processing is actually here shows us in the first co-processing project, and we did in China by Sonoma. That's in Liyang City with a population of less than 100, less than 1 million population. So with the system, we actually co-process 450 tons of mini solid waste and 120 tons of solid sludge per day, and hazardous waste 20 kilotons per year, or combined with 5,000 tons clinical lines, and also considerable economic, social, and environmental benefits can be achieved by this co-processing system. The most important thing I wish to mention that actually is with the equipment of the co-processing facilities, the Liyang city actually becomes a city with zero mini solid waste. And in the recent years, this actually already become a trend, a new mode for combining the cement co-processing facilities with the zero waste cities. We have quite a few projects already completed in China with the goods combination. And the third one, best available technologies, is the low carbon cement. Generally, we can consider Chinese cement is, as a low carbon cement because, when we made a very simple calculation, we can see that the direct CO2 emission intensity of Chinese cement is something around 0.56 tons CO2 per ton of Chinese cement. So in that we consider accordingly we can calculate quickly the direct CO2 emission last year for Chinese cement industry. That's something around 1.3 billion metric tons. Specifically with Chinese characteristics, as I already mentioned, we have developed and utilized low carbon clinker cement with the CSA or belite as principal minerals. So, and I believe actually this kind of low carbon clinker cement will be also very good alternative in the future in terms of materials solution for innovative material solution for future cement industry. I wish also actually say a few words about the national project we are doing now in China, supported by the Ministry of Science and Technology of China. The project is an international collaborative project. We appreciate actually the international partners led by Professor Karen Skriner from EPFL and Professor Martina from Cuba, Professor Bishnoi from India. Actually, with the collaboration, we have 6 partners, to work on this new low carbon cement, focusing on using the calcined clay. This new type of low carbon cement we are working on. We expect actually the cement can use 50% of the clinker factor of the low carbon cement is 50%. But even with 50%, 45%, something around 45% of clinker replacement, we expect to achieve equivalent 28-day strength compared with pure Portland cement without any addition of blending materials. And also the new low carbon cement can also exhibit excellent durability and so forth. The second important milestone for this project is to develop the suspending calcination technology. This is a kind of a flash calcining system. We expect to use such kind of system actually where you can produce the calcined clay more energy efficiently. So we are also demonstrated the project outcome by trial production of calcined clay with 600 tons per day the calcined clay just in the system. Here actually so the raw materials we identified in China is kind of a intermediate waste from the beneficiation process of kaolinite in southern China, where actually a lot of such silicate to soft clay, kaolinite clay actually can be found there. The key issue, of course, is the the LC3 is to thermally activate the clay. The best performance can be given by the kaolinite bearing clay raw materials with the calcination temperature something around 700 up to 800, depending on the time and the content of the kaolinite. The research actually is also a review that 40% of the kaolinite content in the raw clay is very good enough for producing the high quality, the good quality for very low clinker factor of low carbon cement. Certainly, the higher the content of kaolinite, the better its performance, and the larger the replacement of clinker for the production of low carbon cement. We actually successfully made the trial production of the kaolinite clay by using the flash cast ironing system we design and we designed for the Chinese for the Super our clients, Super New Materials Company in Zhejiang, in Zhenjiang, Jiangsu province. We actually made the trial production 2 years back. And also the thermal consumption of the system is believed it's less than 500 kilocalorie per kilos of calcined clay. That's just for the calcination. We also I must say that here the flash calcining system is very versatile for producing any other type of inorganic minerals. For example, we already actually use the same system to build the facilities to produce reactive lime, but with a capacity of 300 tons per day. It's already completed. We are now actually already received the contract for building calcined clay facilities with a capacity of 1,300 tons per day in China. The best emerging technologies for mostly the CCUS post-combustion. By the post-combustion process, we have actually in China the Anhui Conch, the demonstration project actually is successfully commissioned in 2018. This the post-combustion CCUS project actually was made in line with the kiln capacity 4,500 tons per capacity. Those the total capacity of CCUS is 50,000 tons of CO2 per year, and two type of CO2 products, industry grade and food grade products are being produced within this project, and also the chemical absorption process is used for absorbing the CO2 here actually, so we see that actually the flow diagram of the post-combustion system for the Anhui Conch demonstration project. We have here actually show two pictures of CCUS projects in Anhui Conch cement. The second actually CCUS. We also in China, Sonoma also developed the oxy-fuel and CO2 enrichment process for CCUS technology. With this technology, with this oxy-fuel process, we expect to concentrate CO2 from normally 20-30% to 70 up to 75%. So with the enrichment of CO2, we expect to considerably reduce the capex and the opex of the CCUS system. And also, so also another thing is very important, which to mention that with the CO2 enrichment up to 75% of the concentration, we can use directly of the CO2 enriched for the combination curing to produce actually the carbon cured product. So with that, actually, so we can reduce the cost, is even considered remarkably. And here shows us a flow chart of the system, oxy-fuel combustion system Sonoma developed. We actually already finished the 50,000 tons per year. The pilot project, we are expecting to work with industry, interested partners, cement partners, with the oxy-fuel combustion project. Here we also actually involved in the CCU, the utilization through the mineralization sequestration process. The concept is very simple. We try to use two types of waste, so CO2 from flue gas and also the carbide slag, also a kind of waste from chemical industry, to produce the high value added product, PCC, precipitated calcium carbonate. We already finished the feasibility study of the 50,000 tons per year, the PCC, and we also completed the industry project to produce the precipitated barium carbonate with the same capacity, 50,000 tons per day. So though it's actually capacity for using the CO2, why this mineralization process is very small, only 50,000 tons per year. But I believe this is a very important step actually to take action from now. Finally, a few words about the future perspective. So in terms of cement sustainability and carbon neutrality, this actually is a global issue, but have to be dealt with regionally. So in that aspect, we rely on all aspects to contribute to this sustainability and neutrality. There's no silver bullet. We have to equip with us, different type of tools in our toolbox, to respond to sustainability and carbon neutrality in the future. CCUS certainly is one of the key solutions in the future to the carbon neutrality. So with that, we expect further R&Ds, to reduce considerably the cost for capex and also for the opex. And also, we also need the support from the policy regulation enforcement, standardization, financing, and also cross-border, cross-sector models, business models, and international collaboration. So, and also actually here, I wish to use a slide, and the slide actually I prepared 10 years ago. That I believe that's in terms of the material part, I believe that's the scenario in the future for cement as a binder, as an important binder, to change the present PC as a single membrane, and we're going to produce more low carbon energy emission cement combined with the main dish, the Portland cement in the future. That's actually my short review of the Chinese solution in responding to carbon neutrality. Thank you very much.
Thank you very much. That was a fascinating presentation, and interesting to see, again, going through the alternative fuel solutions, calcined clays, carbon capture, seeing different technological approaches or different environments. In China, the scale of the industry is immense. As you mentioned, over half the world's cement production. What comes to mind is, with these technologies now developed, but still at early stage, how fast do you think they can be adopted by the cement industry in China? And are the drivers there to push this technological deployment? I'm thinking about the the 5-year plan now, and peak carbon is one of the targets. Do you think that's going to now push this technology quite fast? And I'm also thinking back 15 years ago in China, you'd probably be able to tell me more accurately, but the vertical shaft kiln was still the dominant form of manufacturing, and now it's completely eliminated. We know how fast China can move. Do you see the same progression for these low carbon technologies?
Thank you, Thomas. That's a really good question. So in terms of the solutions as I just reviewed. So mostly actually we are using most of the solutions, especially the best practice, best available technologies. So I just actually introduced in terms of the energy efficiency, in terms of the use of alternative fuels, and also the clinker substitution for low carbon cement. Actually, all these actually are best practice we are using now in China, to reduce the CO2 emission and also improve the energy efficiency. And also, these are actually that's for sure we are using, applying all these solutions right now. But most important thing actually is towards the goal of carbon neutrality in the future. That's actually we also have the challenge is there not just for China, it's actually for the whole world cement industry. So the higher cost of the CCUS in terms of the capex, the opex. So in that case, we expect all these different solutions. First, actually, to reduce the cost. First, actually, further R&D expected. Actually, we also rely on also the policy, the government policy, the standardization process. Actually, the cross-border, the collaboration, and also the some kind of the carbon tax, or and also all the ETS system. So all this actually can facilitate the deployment of the future, the best emerging solutions such as CCUS. So I expect in the coming 5 to 10 years, I hope actually there should be actually real industrial project of CCUS coming out in Chinese cement industry. So you mentioned that actually 15, 20 years ago, actually, so the vertical shaft kilns once dominating the Chinese cement. That's really the true things actually. At that time, the largest percentage of vertical shaft kilns cement in China actually takes more than 80%. So that's actually the huge, the change is so huge that even for us actually working in the Chinese cement industry, we feel that that's really big, huge, really. Sometimes we can think that it's really far, it exceed our expectation, in terms of the restructuring of the cement industry. So in that case, we really appreciate actually the strong government policy support, as well as actually the innovations, the technical innovations for Chinese cement industry. That's actually, so I believe all this can happen even in the future. Towards same thing will happen with the CCUS for in the future.
Yeah, well, we hope so, and it is amazing the pace of technological development. So it gives us confidence for the future. Just very quickly touching on the calcined clay plant. There's a few questions around that. What is the energy, the fuel consumption for manufacturing calcined clay, and also can you give any indications on the capex and opex for a calcined clay plant? People are, what is the scale of investment required?
in terms of the fuel consumption, we have only actually search, I can only give you the figure actually based on our trial production with the process we erected in China. What I can say is that the fuel consumption for calcination using the flash calcining system is actually less than 500 calorie, per kilos of calcium clay. But that I believe that's not the best efficiency. We can, there's still room actually to further improvement. So that's we have to rely on our second project with calcination, with the calcination of the clay for capacity 1,300 tons per day. Mm-hmm. That's actually the ongoing project. Hopefully, we can finish the contract and get the project done. I can give you the real data, next time hopefully. For the CapEx OpEx, because I'm the technical guy, I'm not quite familiar with the system, but I believe it's not. I believe it's just not. I can actually, please, if there's real such a need, I can give the contact information of my colleague in the business department who can actually provide such information. Yeah.
Very good.
Is that okay?
Well, that's quite all right. Just to say that we will be distributing the slides after the presentations, and there are some fantastic case studies that you presented as well. The Sonoma Liang project is particularly interesting, where you're disposing of high levels of municipal solid waste, and you have a zero waste city. So maybe a model for the future. So Dr. Tongguo Sui, thank you very much for that presentation, for sharing your insights and participating today. That's all we have time for now. And I'm going to introduce our next speaker, who is Luke Brudowski from ThyssenKrupp Industrial Solutions. And we'll just give you
welcome. Welcome. Thank you.
The opportunity to share Luke. Luke is Head of Innovation and a member of the Management Board of ThyssenKrupp Industrial Solutions Cement Technologies Business Unit. He has 31 years experience in the cement industry, having started as a process engineer and product manager at Technip France. He started at Policius in 1994 as sales manager and then head of business development and sales before joining the management board of the TKIS cement business unit as head of innovation in 2018. And today he's going to talk about grey to green technologies. If you see all grey, move the elephant. Over to you, Luke.
Can you see my screen, Thomas?
I can see your screen. You need to press the presentation mode in the bottom. Yes, that's it. Perfect.
Okay. Good.
Okay.
Thank you very much for the introduction. So I put that in. Sorry, a little bit delay here in the control. Let me come back to the first slide. Here we go. So good afternoon, good morning to everyone. I'm very glad to see here. And yeah, most probably you should ask yourself. What about the title of this presentation? If you see all grey, move the elephant. So in fact, well, for this conference, I have chosen this Indian proverb that I cherish. Well, in fact, in presently we have difficult and uncertain times because of still this COVID-19 crisis, that is pandemic that is hurting us. We have as well, let's say, this climate change crisis, which is, let's say, leading to very necessary changes in our industry towards a more sustainable planet. This is a big challenge for us. And let's say, moving the elephant means that, trying to look beyond the obstacle, being solutions oriented rather than problem focused. Is our mantra with our grey to green journey. And let's say that's what I would like to present today is, let's say, the solutions that we introduce to the market and we are developing quite quickly, I hope. So we launched our Grey to Green initiative and let's say solutions portfolio 2 years ago. We started that in Brussels with 4 solutions. In the meantime, we launched an additional one last year. These are the oxy-fuel solution, NOx reduction, the fuel substitution, and the activated clay. And lastly, we launched the booster mill technology. Let's start with the fuel substitution. I think, well, most of the previous speakers talked about, you know, what is until 2030 the win-win solution. I mean, most of it's related to win-win because it's not increasing the cost of the cement that is produced, but at the contrary, I mean, the cement producer can reduce their production costs and earn money with very rapid, let's say, return on investment with, let's say, waste fuel, alternative fuel, as well as clinker substitution. So let's start with the fuel substitution. We developed this combustion chamber, so-called the Prepol SC, and the short version of it, which is the Prepol SCS. Years ago, we have a lot of references on that. So basically, that's a completely static combustion chamber where you have, let's say on the Prepol SC, tertiary air duct as well as mill in order to have a complete combustion of ultra coarse fuels or very, very low reactivity fuels there, aiming at a complete substitution in the calciner. Basically, the two systems are using the same feeding system here. The difference with the Prepol SC is the size of the combustion chamber, which is in fact used to dry and ignite, let's say, the coarse fuel. It's not completely burning, but it's creating a lot of volatile matter that will then continue to burn into the calciner. This is a perfect, let's say, entry product to start burning alternative fuel. You can understand here the unique, let's say, advantage, creating a strong business case with extremely rapid, let's say, return on investment for substitution rate of, as you can see here, you know, with 50 to 50 millimeter granulometry of the alternative fuel, let's say flyable, then you can see the difference here in substitution rate you can have when compared to direct feeding with low residence time calciner until 4 seconds here. When you are increasing the size of alternative fuel, you still have a big gap when compared to direct feeding, and then going to large pieces of alternative fuel, then you can go to the step combustor. So with these two solutions here, we have, let's say, the ranging, the complete range of possible substitution rates with any kind as well of size of alternative fuel. The SCS has been commissioned last year already, very quickly, let's say, rapidly and successfully in Cementos Artigas in Uruguay, with leading to a 25% TSR over the Prepol SC. The nickname of in South America has been launched by the client already. That's the so-called Prepolito. There they are burning, shredded tires. And we just commissioned in Turkey the second one on the separate line calciner, which is quite interesting because it's not that easy to burn alternative fuel in a separate line calciner. So this product is having a great start on the market. Here is, let's say, a major reference that we are implementing presently for TPI Pauline in Thailand, where the client has 4 9,000 tons per day plant, and we are converting the 4 kilns with Prepol SC, leading to the biggest well incineration plant in a cement plant, together with chlorine system as well. So we developed, as you can see here, let's say, the waste to energy solution for household waste. Yesterday we had the presentation of cemtech, so I guess that's really a good continuation in terms of technology proposal to solve the problem of let's say household waste and plastic from the collection, sorting, treatment, and burning that in our combustion chamber, pre-policy or pre-policy CS. Clinker factor reduction. In fact, we are combining here two technologies because we believe, as it was presented by Paul Roger from Exxon yesterday, that with decarbonated clinker and LC3 type cement, that is the best combination we can have in the future for in terms of production cost of clinker. We believe as well that the clinker will remain, and the graph here is to explain why. Let's say even if the challenge of the A-light here, let's say representing the clinker, that it's emitting the highest amount of CO2 and most energy demanding when compared to a possible alternative like blast furnace slag or fly ash, which is, as everybody knows, let's say with less, let's say, resource available. Metakaolinite is an option, definitely, but still the halite is showing the strongest hydration and reactivity over time. So that means that the consequence is that we will have to reduce the clinker, but still the remaining, let's say, portion of clinker in cement will have to be valorized. And well, I use this term of gray gold because it will remain in the cement industry. So our proposal, in fact, is to combine both technologies here. First of all, what we call the polygus activated clay, which is, let's say, a flash calciner producing activated clay as substitute reactivity from the clinker. And on the other side, let's say, to optimize the reactivity of the remaining part of the clinker, which can be used either to push further the clinker reduction factor when using activated clay, or let's say adding more filler if we are talking about limestone additive there. So in fact, it's as well, let's say, the compensation of the missing clinker reactivity by activated clay that we know at the early ages as well is, let's say, I mean, the booster mill here can offer definitely earlier compensated strengths with finer clinker grinding. Let me explain a bit the principle of the technology. I will not enter in the very detail because I would like to cover all possible topics that we are developing, and we have a lot under development in our portfolio right now. So I'm presenting here the flash calciner. I think, well, that's quite an industry, becoming an industry standard. I have still a lot of questions about rotary kiln. For sure, I mean, there are some rotary kilns producing activated clay worldwide. This is an option for me as well for existing kilns that are, not producing because that would be definitely the lowest capex. But let's say the flash calciner has been selected by us as a favored technology for two reasons. First of all, there is no capex advantage in the rotary kiln, and there is a strong product advantage, product quality advantage for the flash calciner, both in terms of activation, color control, and especially, let's say, the flexibility of using a range of different fuels, from fossil fuels to renewable fuels. So basically, the treatment of the clay Well, depending on the type of clay, because using a very high kaolinite content is a piece of cake, I would say, in terms of activation, low heat energy demand, etc. But in general, the challenge is to use, let's say, clay that are available in cement plant deposits where the kaolinite content is just good enough with high iron content and then the necessity to get gray color, and this is the challenge. So basically the treatment, the pre-treatment is hammer mill and flash drying, then a preheating stage and calcining, and let's say a color control system in order to turn this reddish color that is created by clay during the activation stage in the calcining process down to a gray color in the reducing atmosphere, and then the heat consideration recuperation is done in a flash cooling system with cyclones. We are still let's say making a lot of innovation and development of the product right away in R&D with various clients, and let's say we offer for your project of developing activated clay plants a full range of services from geology survey, raw material analysis, chemical, physical, etc., flash calcining, including color reduction tests in our labs, mortar testing down to cement classification, and the overall business case evaluation. And well, I can tell you that activated clay is a booming product. There is a lot of interest worldwide, and now we are turning into concrete projects. So we have been lucky, but as well convincing enough to sign the first worldwide flash calciner, standalone flash calciner system in Cameroon for Simpo International, which is Oyak Group. This is a greenfield flash calcining activated clay plant as well as cement grinding plant. As you can see here with the clinker storage, additive and clay storage, the flash calcining system here with the flash calcining silo, and here the cement grinding plant with the cement silos, packing and storing. So we are on this project on the construction phase. So now the booster mill, so that's quite a new technology that we introduce into the market. This is composed of 3 elements here. So a feed bin with a feeding system. Then the mill itself, here it's the blue cylinder with a drive motor here, and the dedusting system and collection of the product. So this mill is very well known in chemical industry, cosmetic, food, as well as mining, but that's the first introduction in the cement industry. So as you can see, it's a small chamber with rotating grinding discs there. So here we are on the small velocity with feeding of the bits, this very small 6 to 8 millimeter balls here. So the velocity is quite small. So you have this grinding chamber here, and you have at the outlet a trommel to separate the bits from the material. And when we feed the material, then the velocity of the grinding ring is accelerating, and with a very high energy density. I mean, the power to volume ratio when compared to a ball mill is 10 times higher. So you can imagine that the grinding efficiency of such a system is extremely good. How is it used? Sorry, this is... Let me switch to the other slide. Yeah. How is it used? So for the time being, we are developing the system and a first reference has been commissioned 2 years ago already in Turkey within an existing ball mill circuit. So we are developing this circuit on this technology on ball mill circuit because there is a lot of potential in terms of improvement still. So the system here, as you can see, the booster mill with the feeding system here, can be fed either by the product outside the bucket elevator, mill outlet, let's say, or from rejects from the separator. And let's say the objective is to get a feeding, a granulometry of incoming the mill of about less than 500 microns or 0.5 millimeters. And it's a kind of separate grinding or a third chamber of a ball mill, whatever you want, a separate grinding, because in fact, when you have limestone cement, for example, let's say the clinker percentage within the separator reject is increased. So let's say instead of 75% of clinker that you have in the cement, it's increased up to more than 85%, because it's harder than limestone that is already in the finished product. And then you can preferably, let's say, work on grinding the clinker separately. That's the advantage of the machine. And that's the objective of reducing the clinker factor. So we have been conducting a lot of tests, and I would come to the test results in a minute. Since, let's say, the commissioning of our lab booster mill here that you can see on the screen, since August 2020, 6 campaigns finished and 4 campaigns further. So you can imagine that the machine is occupied every week. It's we are having a lot of collaboration with clients, and we see a strong interest on the market. So what are the results? The results, as you can see here, is that we, let's say, we ground, let's say, the clinker finer in order to increase from this reference cement, limestone cement, this with 17.5% limestone in the cement, up to 24 and then to 30% limestone cement. And in fact, the results are extremely promising, because whereas you can see here the test at 2 days compressive strength, but that's the same at 7 days and 28 days, with still very acceptable workability and water demand. So that I think that, let's say, the potential of reducing the clinker factor by about 10 points is easily achievable, which is on top of what you can do with LC3 cements. And let's say for both technologies, the business case is extremely strong. When you come to, let's say, clinker with high cost, which definitely will happen in the future, because if we want to reduce let's say the CO2 footprint of the cement industry, the next generation of technology, which is supposed to be after 2030, personally, I believe that it will be earlier than that, especially in let's say, countries or regions where an ETS system is applied. Maybe you have seen that in May of this year, the CO2 price in Europe was as high as 53 euro, and when you are touching the 60 euro, then let's say this new technology of carbon capture can be applied. And I see an urgency, in fact, even to be ready to develop this technology before it's even applied. So we have been doing that since a lot of years already. We have been involved in many R&D and innovation projects where we have been comparing different technologies. This is one of the outcomes of one study of cemtech financed by EU, where we are, MEA, scrubbing technologies, which have been say presented by my predecessor this morning, chilled ammonia process, carbonate looping, oxy-fuel, or indirect heating. And let's say the study is showing that oxy-fuel has the best potential in terms of CapEx, OpEx, total cost of ownership. So that's why we put all our efforts in developing the oxy-fuel as a favorite technology first, but secondly, we invented our own oxy-fuel. So what has been presented this morning, in fact, was a first generation oxy-fuel that is on the screen right now. So what is the difference between first generation and the second generation? That is our process, also so-called polygious pure oxy-fuel. In fact, here you can see that in the first generation oxy-fuel, you are replacing the nitrogen from the air. Well, we are replacing, let's say, the combustion of the fuel with air by a mix of oxygen and recirculated CO2 that is captured at the outlet of the kiln here in the first part of the cooler, right? So for that, you need, let's say, you need a heat exchanger in order to recover the heat that you need for drying in the raw mill, your raw material. You need to dedust that, and as well, you need to discharge the water before recirculating, and as well before, let's say, sending to CO2 purification. Well, what we developed, in fact, is the pure oxy-fuel in order to, and you will see that the separation in the cooler here between the first part where we are blowing CO2 and oxygen and the second part where you are blowing air. In fact, this separation is moved in the first part of the cooler here. Why? Because we are not recirculating any more CO2 here. We are just blowing pure oxygen, and the name of the pure oxy-fuel is because of that, in the first part of the cooler, and then we can, let's say, accordingly remove the condenser, remove the tertiary air duct, remove the heat exchanger, as well as, and that's the major effect, reduce the size of the preheater by half, right? So let's say this pure oxy-fuel technology is accordingly very cost-effective, very simple in terms of process, in terms of layouts, and this represents a unique process improvement because you are burning with a much higher oxygen content, and this has many benefits to the clinker quality, expected clinker quality, as well as the AFR amount. So that's why, let's say, we are involved in several pure oxy-fuel projects, and let's say I think we are quite advanced, and that's why CI4C, which is a joint venture of 4 global players, cement global players, which are Heidelberg Cement, Buzzi, Unicem, Schwenk Cement, and Vica. They came to us, let's say, to consider the use of our pure oxy-fuel technology in the demonstration plant, which, well, this is just an image, but and so we hope that we could. So we are quite advanced in terms of development, and we hope that we could, let's say, launch the construction of such a demonstration plant very shortly. The second project I can share, there are many others, believe me, is this Westkuste project. That's a carbon, the sector coupling project where offshore wind producer, a refinery, a cement plant of Lafarge-Holcim in Legerdorf, and let's say a gas grid connection is launching a carbon capture and usage project where the green energy will generate hydrogen that will generate through electrolysis hydrogen and oxygen, which will be used on one hand, let's say, to generate pure oxy-fuel process to capture the CO2, and on the other, let's say, use the hydrogen to combine with CO2 into a methanol synthesis and then generate in a refinery green aviation fuel. Definitely, we think that the CCS, and there is a lot of progress in terms of CO2 infrastructure, especially in North Europe, like this Portos project, Northern Light, etc. But we believe that if we can create a value with generating a usage like green fuel, definitely that will come much more economical, because overall the process of capturing the CO2 is very energy demanding. So as a summary of my presentation here, let's say you have seen that in all the decarbonizing roadmap of the cement players, there are two dates, 2030 and 2050. 2030 is, I would say, conventional technology, business as usual, contribution to reduction of the clinker costs. So there we are well equipped with our Prepol SC, booster mill and activated clay for this three abatement technology for CO2. But we are as well quite prepared on the oxy-fuel technology as a carbon capture favorite technology, let's say, for the next stage. We are working as well on other projects, but we want to talk about this technology when we are ready to launch that on the market, and not as possible greenwashing or something. Thank you very much for your attention.
Thank you very much, Luc. Another fantastic presentation that you've covered so much new technology. It's great to see things like the booster mill coming in and bringing in technologies from other industries. The calcine clays as well, and the first facility already under construction in Cameroon. Various questions. What is the capacity of the calcine clay plant that TKS is currently building? And I guess another question is, can these operate as standalone production facilities and serve maybe a ready mix on their own? Is that another possible model for these?
Oh yeah, absolutely. I don't want to be to make our cement clients angry, but I think there is a lot of interest in the concrete industry as well, which somehow the cement players are in competition with some concrete players that are active, like with strategic assets on the granulate side, for example. But there is strong interest on the booster mill, but as well on the activated clay standalone plant. There is an interest as well in, let's say, construction waste material usage into activated clay plant. Yeah.
Okay, and in terms of CapEx, I mean, the flash calciner system and everything, are there any kind of ballpark figures or parameters that you can share with us? For what kind of scale are you building now, and what is the kind of investment required?
Thomas, I think that's I would like to communicate about that quite transparently, but for various reasons I will not. But let's say I invite the cement players that are assisting to this presentation to contact me, and we will be extremely glad to give a precise answer on that. I guess you can understand easily why I'm not sharing this. This is, we are still in the battle of concept, I think. Mm-hmm. So I have a friendly competitor attending to the meeting today. And until the technology is really, let's say, completely developed with, this battle of concept a little bit more precise, then we could communicate such a figure. But it's a kind of strategic information for now.
And looking at the booster mill, this is it something that can work in a standalone system, or is it always in combination? Like you described it as the kind of the third chamber of a ball mill.
Yeah.
So you always see it within the context of a grinding plant.
That's not a standalone solution. You cannot grind. As I said, the granulometry has to be limited to all passing to 2-3 millimeter, and let's say in average less than 500 microns. It's it's a plugin that we see in order to improve existing grinding systems. So there is a lot of possible applications. Here we are concentrating for the time being on the ball mill, but I see, for example, in Asia especially, where VRM is a lot used in cement grinding for high resistance cement, and where some, are struggling with problem of performance, I think there is a great possibility of improving the performance in terms of strength for this particular type of cement with the VRM as well.
Yeah, and so I mean, it has two functions. You can either choose it to use it to improve the strength of your cement, or you can use it to reduce the clinker volume in your cement. Yeah. And you show those examples with 30% clinker replacement.
Exactly. So in fact, there is three applications of this system that have been shown in the first reference in Turkey. Capacity increase of an existing system. Let's say putting much more fineness in the system, especially in the range between 2, 3 and 10 microns, let's say shifting the curve to the left, as well as reducing the clinker factor. And this is the great advantage of this mill, is that it has the flexibility to work on the three at the same time.
Yeah.
Depending on the portfolio,
Sure, understood. And just very briefly on the oxyfuel. So this technology, I mean, it's a later technology. It's now being developed, really. You've given us a taste of the future. Do you envisage it to be retrofitted to existing preheaters? And is there a kind of cost target for the pure oxyfuel, or is that too far off as well?
Well, first of all, I'd like to say that it's not because we have, let's say, an ETS system with very high CO2 prices already traded on the market in Europe that there is no interest in other parts of the world. We are talking on oxyfuel project in Asia, in North America, as well as in South America. I mean, there is a strong interest because all the cement industry knows that they have to prepare themselves first. Secondly, the target, it's clearly to show, let's say, the feasibility of such a technology, and we have to cross, let's say, in terms of pure oxyfuel for the complete capture of a cement plant, we have to cross that line of delivering. So that's the objective of hopefully the CI4C project. Now, in terms of partial conversion, yes, we are working as well on various options, possibilities, and I would be glad to exchange with potential, let's say, interested clients here.
Thank you very much, Luc. That was an excellent, pleasant presentation. We'll be sending that round to all participants in due course. But for now, thank you very much indeed.
My pleasure. Thank you, Thomas.
So we're going to move on to our fourth and final presentation of the session. And I have to thank Bruno Fuchs for being so patient. We're really looking forward now to hearing his presentation. Bruno has spent more than 15 years of his professional career in sustainable waste management for major multinational companies in the construction industry. As part of the executive committee of INSEE Vietnam, he is proud of the company's achievements in the green manufacturing, the circular economy, and sustainable development in general. Today he's going to talk about biomass and how it can contribute to Asia's transition to a low-carbon future. So, over to you, Bruno.
Thank you. Thank you, Thomas, for the nice introduction. Thanks as well for the invitation, and I'm really pleased and as well honored to be part of this